Okay, so today we're going to talk about how to simplify, let me get my camera here, how to simplify radicals. But before we do that, we have to understand what a radical is. So I'm going to explain that first before we even get started, okay? What you need to understand is that a radical is the opposite of a squared or cubed. For example, x squared, the opposite of squared is the square root. The opposite of cubed is the cube root. Just like we have the opposite of division is multiplication, the opposite of addition is subtraction. We have all of those things. We need to understand the opposite of squared is square root. The opposite of cubed is cube root. For example, if I have x squared, but I take the square root of that, the square root and the squared cancel, and I'm just left with x. If I have x cubed and I have the cube root of that, the cube root and the cube cancel, and I'm just left with x. Those are opposites of each other, and we need to remember that. So let's move on, and let's talk about how to simplify expressions using radicals or with radicals in them. For example, if I have the negative square root of 25, and I need to simplify that, I know that 25 is 5 times 5. So that is 5 squared. And since the squared and squared are opposite, those can cancel, and I'm going to get negative 5. For this one, I'm going to go ahead and change it to a fraction. In order to do that, I need to know how to change it to a fraction. Since the 1 is in the thousandths place, that means the fraction is actually going to be 1 over 1,000. And then we're going to distribute that cube root, just like we can distribute exponents, into the numerator and the denominator. So I have the cube root of 1 over the cube root of 1,000. Cube root of 1 is 1. Cube root of 1,000, well, if you're not sure, go ahead and break it down. That's just 100 times 10. And 100 is 10 times 10, so I have the cube root of 10 times 10 times 10, which is the cube root of 10 cubed, which is just 10. Cancel, cancel, 1/10. If you plug this into a calculator, you get 0.1, which is 1/10. All right. Now, we need to understand something before we move on, and that is understanding signs when we're talking about square roots, okay? And I'm going to go ahead and just do this on a separate sheet of paper. So, to understand signs, let's talk about what is negative 2 squared. It is positive 4. What is 2 squared? Positive 4 as well. So, what is the square root of 4? Technically, it could be positive or it could be negative 2. So that's why we always say the square root is plus or minus 2, because the root could be 2 or negative 2. However, when we take a cube root, if I have negative 2 cubed or 2 cubed, this is going to give me negative 8. Negative 2 times negative 2 times negative 2, or 2 times 2 times 2, which is positive 8. So when we have a cube root, the cube root of 8 is negative 2. We don't have two possible answers. And the cube root of positive 8 is 2. So we know that only gives us one possible solution. So here's the deal. When you take the square root of something, okay, we know we can have two solutions. However, we know that we can never have a negative underneath the root. What is the square root of negative 4? Well, what two numbers can you multiply or square and get a negative? Well, you can't, because if I put negative 2 in here, I get a positive 4. If I put positive 2 in here, I get a positive 4. So this is not possible. So we have to make sure that when we get our solutions, if we have any odd exponents, we make sure we have the positive solution of them. Okay, and that's why this rule applies. When you are taking the even root of a variable and the outcome has an odd power, you must use absolute value bars to make sure that odd power only has a positive solution. So let's go ahead and try some of these. How do I solve problems with radicals? I'm going to go ahead and split it up to start. I have the square root of 81, excuse me, and the square root of x to the 4th. Square root of 81, well, I'm just going to take 9 times 9, which is 9 squared, cancels, and I'm just left with 9. Here, you can do this multiple ways, but I'm going to just put, okay, this is x squared times x squared, which cancels these two out. I'm left with x times x, which is x squared. Okay? Even root, remember, even root, odd exponent or odd power, which I don't have any odd powers, so this is just my final answer. Let's try this one. Square root of 121, the square root of y to the 10th. 121 breaks down into 11 times 11, which is 11 squared. Cancels out, and we have 11 over here. Now I'm going to show you another way that you can do this using power properties or exponent properties like we talked about in the previous lesson. You can also put this down as y to the 5th squared, because we know that a power to a power, we are going to multiply those, which would give me to the 10th power. So what happens here is that my outside cancels, and I'm just left with y to the 5th. So I have 11y to the 5th. Now let's look at our rule. Even root, which we do, even root here, odd exponent, we need absolute value symbols. So I need to put an absolute value symbol around the odd power. This is an even power over here, so I don't need absolute value symbols. But I have to make sure this answer is positive because we know a square root solution cannot be negative. Just like the square root, we cannot have a negative solution. We just talked about that. So now let's simplify some examples and you can try it out. So I have the cube root of negative. So since this is a negative, I know the solution is going to be negative, just like we talked about the negative 8 and the positive 8. So now I have 8 over 1,000. So I'm going to go ahead and break those down, and I have 4 times 2 on the top, and I have 1,000 on the bottom, or I'm sorry, 100 times 10, and I'm going to keep breaking them down. So I have 2 times 2 times 2 over 10 times 10 times 10. Now what you have to remember is this is 2 cubed and 10 cubed. So I have negative cube root of 2 cubed, and I'm going to go ahead and distribute my cube root so you can see that, and 10 cubed. That's a cube root, by the way. That kind of looks like it's a 3. So now what happens is I can cancel out my cube root and cube. So I'm left with negative 2 tenths. You can put this answer in. It is correct. However, it's not simplified, so I would simplify it to negative 1/5. Let's try another one. So for this one, you want to go ahead and simplify the inside first if possible, but this one does not simplify, so we're going to go ahead and break it down. So I have the cube root of 64, which is 8 times 8. And then over here, I have the cube root of, I have x to the 9th on the top, which is the only variable, so technically I don't need that. All right, so 8 and 8, and I have 343. So I'm just splitting up my variables, and I'm splitting up my numbers so that I can break them down. 343 is 7 times 49, so I'm going to change that to save a little time. I'm breaking down 343 into 49 times 7. So I have the cube root of 8 times 8, which is 4 times 2 times 4 times 2. And on the bottom, I have 7 times 7 times 7. Here, if you look, I have 4 times 4, and then 2 times 2 is also 4, so the top is 4 cubed, and the bottom is 7 cubed. So I have the cube root of 4 cubed and the cube root of 7 cubed. Those cancel, and I'm left with 4 sevenths. Now to simplify my variable, this is just the cube root of x cubed cubed. Now I'm going to cancel out my cubes, and I'm left with x cubed. So down here I have x cubed. Now you could write this differently if you wanted. You could have 4x cubed over 7, and that's what it would look like. Now, when we finish even root, well, we don't have an even root, we have an odd root, so we don't need to worry about absolute values. It'll tell us if it's positive or negative. For this one, it's very simple. We're just looking at, don't let the m minus n confuse you. A lot of students want to go ahead and distribute this 4 into the m and the n, but you can't do that because there's a subtraction sign there. So don't distribute it. All you have to know is there's a 4th root of a 4th, so you're going to cancel and you're just left with m minus n. But the problem here is, don't forget, even root is 4 even. The 4th root, yes. That means we have an odd exponent. This is to the first power, so we have to have absolute value symbols. And that's why that one is there. Oops. So let's look at this one. When we have the cube root of 45 times the cube root of 75, we can go ahead and combine those underneath one radical, 45 times 75, and then break it down and take out our perfect cubes. We want cubes because it's the opposite of the cube root. So when I break this down, this becomes 9 times 5, and this becomes 25 times 3. And if you use different numbers, that's okay. You're going to end up with the final same answer, as long as you don't make a mistake. So this gives me the cube root. I'm going to break this one down into 3 times 3. 5 stays. 25 into 5 times 5. And my 3 stays. And I'm looking for perfect cubes. Well, 5 times 5 times 5 is 5 cubed. 3 times 3 times 3 is 3 cubed. So I have the cube root of 3 cubed and 5 cubed, which cancels. And I'm left with 3 times 5, 15. Same thing here. We're going to go ahead and combine the two underneath the radical. So I have the cube root of negative 16 times 4. Remember, if we have a cube root of a negative, we can do that. We just have to put it out in front. So break down your 16 into 4 times 4, and then we have times 4, which is the cube root of 4 cubed. Cube root is the opposite of cube, so we can cancel. We're left with negative 4. Now this one, before you get started here, make sure that you undistribute your square root, which means put all of this under the same one and then simplify your fraction on the inside before you take the square root and simplify it with the root. Meaning 54 divided by 2 is 27, and when we have a power, as long as the bases are the same, we can subtract the exponents. 5 minus 2 is x cubed, 3 minus 1 is y squared, and now we can break this down. I have the square root of 27, I have the square root of x cubed, and the square root of y squared. Simplify each part. This is 9 times 3, which is 3 times 3 times 3, which is 3 squared times 3. And remember, we can only cancel out the squared, and whatever's still left in there has to stay underneath the radical. So I'm going to go ahead and cancel the square and put the 3 outside of the radical, but I still have the square root of 3 on the inside here. This one comes out because it cancels, but that one has to stay because there's nothing that cancels. Here, same deal. I have x squared times x. The only one that we can cancel out and take outside of the square root is the one with the square. So I'm going to cancel it and take the x out, but that one has to stay underneath because there's nothing to cancel, therefore I have to leave it underneath the radical. This one works out perfectly, we're just left with y. Now we have a bunch of final answers here in red. We have to put them in the correct order for our final. Go ahead and put your number first, which in this case is 3. So I have 3, and then your variables in alphabetical order, so 3x, y, and then I'm going to put what's in my roots, square root of 3 and x. Even root, odd exponent, absolute value. Even root, which is square root, it has an even root of 2, odd exponent, these both have an exponent of 1, we need that absolute value symbol. All right, let's try another one. Here, I'm going to take my 7 and 2, so I have 7 times 2 out front here. Combine your numbers, 3 and 6, and then you have your x's, x cubed, and then I have my y's, y squared times y. And we're looking for squares since we're finding the square root. Well, 7 times 2 is 14. Here I have 3 times 3 times 2, which is 3 squared times 2. Now I can go ahead and cancel my squared. I'm left with that 3 times the square root of 2. Cannot cancel this one out because it does not have a squared. So now let's go over to my cube. This one is just x squared times x. Why do I write it like that? So that I can cancel out one of the squares. So this one would come out here, and this one stays on the inside. Here, I'm going to go ahead, cancel out here, take my y outside, and I'm left with the radical of y on the inside. Now we have to organize it correctly. 3 comes first, and then my variables in alphabetical order, and then whatever's in the radicals has to go next. So I have 2xy in the radical. Even root, odd exponent, absolute values, and that's your final answer. All right, we're going to go ahead and stop there.